Welcome, Red Eyes members. Thank you for tuning in. Great to have you along with us. We are talking with Nassim Haramein from the resonanceproject.org. We are talking about the grand unified field theory, basically the power of spin, geometry, the structure of the universe, down to the from the biggest universe structure, as it were, down to the size of smaller things like atom and so forth. And I want to begin this segment to get into some of the information that Nassim mentioned in his DVD, Crossing the Event Horizon. Basically, you proposed the idea that we are the center of everything, meaning that we are the center of creation from our perspective as we see things. Everything is happening around us, and we are in the middle. And Nassim, maybe you could expand a little bit on that idea and tell us a little bit more about what you mean with that.
Yes, it's like if you thought of our universe as a fractal structure, like our planet is embedded in the solar system, and the solar system is embedded in a galaxy, and the galaxy is embedded in a cluster, which is embedded in a supercluster, which is embedded in our universe, and we think of our universe as a multiverse, so that our little universe is embedded in a larger one, and a larger one again, and so on. There's infinite amount of boundaries. That means that there is no boundary that you can actually define a center from. Every point in that system, in the fractal structure of space, is the center, and I mean that literally, because you can say, well, I'm not the center of this universe. Well, that's true. You're not the center of this universe. However, if there's infinite amount of larger universe, there's one of those extremely large universe that you're the exact center of. And so everyone experiences the universe from its own point of center. And it might sound arrogant to think that way or to say that like I'm the center of the universe.
Right.
But actually, I think that it's only arrogant if you forget that everybody else and everything else is the center of their universe as well.
Right.
And so it really kind of it's a dance between all of the realities interacting together.
Very interesting. And I mean, if we think about it as individuals, as aware individuals, everything. I mean, you are literally the center of your universe, because you can't, at this point at least, where we are stuck, as it were, in quotes, within our bodies. We can't go further out from that, at least not in the normal awakening state, if you will. So it definitely rings true to me,
Yes. Well, so for instance, if you take a cup and you have 6 people around that cup, everybody is going to see that cup in a different way. Everyone is going to have a different perspective on it, and you will never have the perspective of the other person, and that other person will never have your perspective. However, because you're all part of the same vacuum structure, because there's this fundamental geometric lattice that connects all things, you will all agree that in general it is a cup, and in general it's approximately this color and all this. So there's a consensus reality that emerges out of the connection of all the individual realities interacting with each other.
I mean, that is interesting if we talk about things. For instance, if we are out after the truth, so to speak, there are so many different perspectives in our world, and misunderstandings arise so easily. Because if we think about it, if we place a cup, as you mentioned, in front of a table for, let's say, a few seconds, and then we take it away, maybe at that point there would even be different stories of what size and what color the cup had. But what does that do to a model like you presenting us to it now? Is there such a thing as an objective reality, or is everything subjective?
Well, that's a good question. That's the beauty of a fractal structure, the beauty of a fractal concept of the universe. In a fractal, you have a very specific defined equation that gives a very specific answer, like an objective reality. But when you take in a fractal, you take the answer and you feed it back to the equation, you get a different answer, and you feed it back to the equation, you get a different answer again, and all this. And as you do more and more iteration, it gets more and more nonlinear. It goes towards infinite amount of possibilities, so you get a subjective result. And so objective and subjective are part of that feedback loop. And what I mean by that is that what you could say is objective is always subjective to the position in which it's observed. And so that in fact whatever is happening within the millisecond, you could say, of the now moment is always objective, but since all possibilities exist in the next now moment, it could all change, and so it is ultimately subjective. So both exist.
Very interesting. And I mean, this sounds to me also a little bit like it's connected with theories like let's say the holographic universe, or I mean, is it very similar, the models here that we're talking about?
Yes, it's similar. I actually the theory is called the holofractal graphic theory, and so it uses holographic concepts. But I use fractal structures because they're mathematically they're geometrically formed, and so it has more of it gives us a better description of the dynamics of creation. So it has holographic concepts, but it is defined in fractal structures in geometry, and that as a fundamental structure of the vacuum in space, that from which everything comes from and returns to.
Interesting. And at the beginning, we were talking about the dimensions basically, and you told us a story that your teacher referred to as it's not until we're up at the third dimension that things actually are beginning to exist and so forth. But within your model, have you come up with a concept that explains how many dimensions there actually are at this point?
Yes, in my model, dimensions are not a point, a line, a plane, and a cube, which I think that is a concept of man, not a concept of universe. In my model, dimensions are scales in the fractal structure. Every iteration of the structure is a scale relationship that defines a dimension, if you'd like. And so instead of thinking of a point, a line, a plane, and a cube, you would think of a point embedded into a larger point, embedded into a larger point, and again, and every embedment is a different dimensions. For instance, if you had a very, very, very small person, the size of an atom, and all of a sudden you took them from that size and grew them to the size of a human being, they would definitely think they've changed dimensions. Did they change dimension? No. They changed size dimension. That's the only thing that has changed. And so their experience is widely different because all of a sudden they are not looking at the inner atomic space, like where they would see other atoms far away from them. All of a sudden they're looking at grass outside the door, or they're looking at trees and so on. And so they would say, oh, I've changed dimensions. And so what I'm saying is that dimensions in my model are just different scales, and each scale is embedded into another. And so if you look at the DVD set, there's a set of mathematics that we wrote that it's called a scaling law, and we show that all the scales from infinitely small, from very, very small, like the Planck's distance, which is a point at the center of a black hole that is like extremely small, billions of times smaller than an atom, to the atomic structure, to the solar structures or stellar structures, to galaxies, to quasars and all this. that like they're all on a linear scale from infinitely small to infinitely small to infinitely big. That there's a scale relationship, that the universe is ordered in its scales. It's not just random.
But it still suggests that it's a limit to it. Things cannot become infinitely small or infinitely large. Do I understand that correct then?
No, it suggests that they can. It suggests that there's probably larger scales outside of our outside of our universe that we're not, aware of because we're inside our universe. Yeah. And it suggests that the atom has infinitely smaller scales that go probably past the Planck's distance, past the singularity, into smaller and smaller scales to infinity. And that's why I believe, and from my theory and in my scaling law that's on the internet, you can read the math for it, I actually show that the atom is a mini black hole because it has infinite amount of particles in it, infinite amount of possibility of particles, because you can keep dividing it. And our science today keeps building faster and larger accelerators, like the one they're building in Switzerland, that's costing $10 billion and so on, to get smaller and smaller and smaller particles by smashing atoms faster and faster and faster together. But I believe that you can do that to infinity.
That's very interesting. So, I mean, right now, I guess the many of the scientists, they're looking at the, I guess they're somewhere at the superstring theory that, okay, we can take it apart and so forth. But, I mean, what do you think will yield from some of these experiments that they are doing down in CERN? Will this be like another box within another box within another box? This could go on infinitely then, I guess. Is that right?
I think so. And I think we've reached practical limits in building larger and larger accelerator, and I don't think it's telling us that much valuable information about the universe. What we should look for, instead of some fundamental particle that can no longer be divided, which I guarantee you will be divided again, what we should look for is the pattern of division, how things divide, and what makes them divide at very specific intervals, so that we can understand how the universe does this and harmonize our technology and our understanding to it.
Interesting. And you mentioned that the nucleus of an atom basically is a black hole. Tell us a little bit more about that. That sounds very interesting.
Well, according to my theory, since it can be divided to infinity, then there's infinite amount of mass available in the atom. And so I started to write mathematics to describe that. And I realized that when you actually, describe the nuclei of an atom as a mini black hole, like a teeny weeny black hole, you get all the correct information as far as the atom radiation levels and the amount of force involved inside the atom and all this. It comes out, and you get rid of all sorts of eccentricity that really we added in the model of the atom just because we couldn't find other solutions. One of them is the strong force. We believe there's a nuclear force that is not gravity, that is a very, very strong force that holds the atom together, because when we look in the nuclei of an atom, we find protons. Protons are little particles that are positively charged. And if you have positively charged magnets together, closer you put them together, harder it is to push them together.
Yeah.
So you can imagine that highly charged particles, very, very compacted, inside the nuclei of an atom, would take a lot of force to compress that together. And when